Welcome to a video that will show how to determine the angle between two planes. The acute angle between two planes can be determined using the two normal vectors of each plane. The cosine of the acute angle theta is equal to the absolute value of the dot product of the two normal vectors divided by the product of their magnitudes. A couple things we do have to remember. If the planes are parallel, then the two normal vectors will be scalar multiples of one another. And also, if the planes are perpendicular, then the dot product of the two normal vectors will equal 0. Let's go ahead and take a look at an example. Again, the key in order to find this angle is going to be to identify the two normal vectors to the two planes. We should remember from a previous video that it's pretty easy to find a normal vector to a given plane in general form, as we see here, because the coefficients of the variable terms will give us the components of the normal vector. So looking at this first equation, the first normal vector will have components 1, negative 2, 4, and the components of the second normal vector to the second plane will be 2, 3, and negative 1. So this tells us that cosine theta is going to equal the absolute value of the dot product of these two vectors. So we'll have 1 times 2, that's 2, plus negative 2 times 3, that's negative 6, plus 4 times negative 1, that'll be negative 4. And we'll divide this by the product of the magnitudes of these two vectors. So let's go ahead and find the magnitude of each of these vectors. The magnitude of the first normal vector will be equal to the square root of 1 squared plus negative 2 squared plus 4 squared. And that's going to give us the square root of 1 plus 4 plus 16. That's a square root of 21. The magnitude of the second normal vector is going to be equal to the square root of 2 squared plus 3 squared plus negative 1 squared. That's going to give us a square root of 4 plus 9 plus 1. That'll be the square root of 14. So that tells us the denominator here will be the square root of 21 times the square root of 14. So we'll have cosine theta is equal to, so the numerator is going to be the absolute value of negative 8. That'll be 8 divided by the square root of 21 times the square root of 14. So if we have cosine theta is equal to 8 divided by the square root of 21 times the square root of 14, we know theta is going to equal arc cosine of this ratio. So let's go ahead and go to our calculator. Let's make sure that we're in degree mode. Notice in the third row that we are in degree mode. So now we're going to press second cosine. Our numerator is going to be 8 divided by a denominator of the square root of 21 times the square root of 14. Go ahead and press enter. Looks like the acute angle between these two planes is approximately 62.2 degrees. Let's go and take a look at the graph of these two planes to verify our answer. So here we have the graph of the two planes on the XYZ coordinate system. If we angle this correctly, like this, you can see that when these two planes intersect, we have an obtuse angle here and an acute angle here. This acute angle here does look like it's approximately 62 degrees because it does look like it's more than 45 degrees but less than 90. So it looks like that angle of 62.2 degrees is accurate. Let's go and take a look at one more example. Let's go ahead and identify the two normal vectors. Looking at this first equation, the components of the first normal vector will be 4, negative 3, 1. And the components of the second normal vector, or the normal vector to the second plane, will be 1, 4, 8. Let's go ahead and go over to our formula. Cosine theta is going to be equal to the absolute value of the dot product of these two normal vectors. Let's go ahead and find that. It's going to be 4 times 1, that's 4, plus negative 3 times 4, that's negative 12, plus 1 times 8 would be 8. Now if we take a look at this sum, it's going to be 0. Remember, if the dot product of these two vectors is equal to 0, then these two vectors are orthogonal or perpendicular. So if the normal vectors are perpendicular, then the planes would also have to be perpendicular, and therefore the angle between these two planes would be 90 degrees. So in this problem, we do not have to determine the magnitudes of the two normal vectors because we notice that the dot product is equal to 0. Again, let's go ahead and verify this with a graph. Here's the graph of those two planes. Again, if we angle this correctly, we should be able to identify the angle between those two planes as a right angle. It's a little bit hard to do, but you can see here that those planes do intersect, and it looks like it would be a 90-degree angle. So these two planes are perpendicular. Okay, that's going to do it for this video. I hope you found these examples helpful. Thank you for watching.